Yeah, and then.
So let's get to this so you guys can get your assignment done. You're going to be doing slope with a line given. So the formula that you've been using with the y2 minus y1 over x2 minus x1, you don't have to actually do the math today. You just have to know how to count. So we're going to be given lines and we're going to be asked to find the slope between the lines, or I don't know how to say that. Find the slope of the line that passes through some points like this. So say I had a line that looked like this and someone gave me the graph and said, find the slope. Have you guys done this before?
Is it where you?
Yeah, so you make these things called a rise and a run. And the thing about the Delta Math assignment today is it won't let you answer the question until you've constructed the rise and the run. So the trick is that you have to pick a point where you want to start. I'm trying to do a much better job. I think there were a couple people that I kind of my lesson brushed right past last hour, and I think that's on me for doing a pretty half-hearted job. So let me show you what this looks like. The first thing you have to do is pick a point that is a good point. We call these lattice points. And I would circle them for you here just to show you what I mean. Like this is a lattice point. That's a lattice point. Lattice. What do I mean when I say that?
It's like where it touches
It's locked onto an X and Y axis grid line. We call that a lattice point. So we want those, okay? So make sure that when you start that you pick a lattice point. And what we're going to do, and I'll show you this on Delta Math here in just a second, is you're actually just going to click a point. So like, let's say I clicked up here and I'm going to drag my mouse cursor until I get across from another lattice point like this. And then, so you have to click once to start the rise and click again to stop. And that'll make a point right here where I'm moving my mouse. But then you have to click again and then again. So you wind up having to click 4 times, once for each start and stop for the rise and the run. And then you just have to know how to count and not say silly things. So this right here is what we call the rise. I know it doesn't necessarily go uphill, but a downhill movement is still a vertical rise. It just happens to be a negative. How long is that vertical drop?
3.
That's a difference of 3. So the rise we say is 3. And some people would have you believe that it's -3, and that's totally fine too. But I'll just give you my perspective on this when I'm done. So I just see it as a length of 3. How long is my run going across? I believe it is 6. Yes. If you count out the jumps that it takes to get from here to here, it's 1, 2, 3, 4, 5, 6. So we say that the run is equal to 6. And then all you have to simply do is make sure that your fraction is in the delta y over delta x. In other words, rise over run. Always make sure your y's go over your x's. So the rise is 3. The run is 6. And reduce that down, what do we get? Now, I would just tell you, if you were to type this answer into Delta Math, it will be wrong. And why is that? Good. And this is where most mistakes happen, is, when people call me over and say, I don't get it. It says I missed this. I don't understand. I'd say more often than not, it's not that someone doesn't generally know how to count out a slope. It's just that we forget the basics, that if a line goes downhill, like this one obviously does, then the slope has to be -1/2. So if you want to be very literal about this, you could call the rise a value of -3 since it's going down, and then the run could be a +6, and then that gets your negative into the fraction earlier. My take, and I've taught this for so many decades, that my stance on it is just build your rise and your run with numbers, and then just don't be a knucklehead. If it goes downhill, slap a negative on it when you're done. If it goes uphill, don't. That's all.
If it were to ever go down, would it be a positive?
It would. Yeah. I mean, just at the end of the day, just look at the line. I mean, the bottom line, when all is said and done, is if your line points like this, it's positive. If your line points like this, it's negative. But it's like a negative and a negative if you want to look at it that way. Not wrong at all. So I want to show you what it looks like on Delta Math. By the way, there are no vertical and horizontal lines in this assignment. And if I'm wrong, okay, but don't get out anything yet. Just when I clicked through your assignment, like I clicked like 100 times, I could never find a vertical or horizontal line. So that'll come tomorrow on the paper assignment that I have for you. But if it were to happen, if Delta Math gave you a vertical line, what would you say the slope is? It is undefined or no slope. And if it were horizontal, then it would be 0, right? I do not think you're going to see any of those today. So for the last part of this, let me show you how this works, and then I'll get out of your way. But again, just keep hanging out here. I gotta gotta get that to go away. Get back to this. There we go. So here's an example right here, and I'm going to get zoomed in on this as much as I possibly can so that you have a shot at seeing it. So what would we say first off about this slope? Yeah, it's positive. And does anyone already know what the slope is? I see that it goes up 1. It looks to me like it goes up 1 for every 1 that it goes to the right. Now, let's say you didn't spot that, right? And by the way, on that last example that I did, would you guys agree that I could have saved time instead of going down 3 and right 6? Couldn't I have just gone down? Like, look at these big fat purple lines. Like I could have gone down 1 and right 2, right? And that's still, look at how that's the same tilt. It's still a 1 to 2 ratio. It's just, so if you can find quicker pathways, more power to you. But on this one, would you agree that it's up 1, right 1? So this is what Delta needs you to do, is pick a point, and I hope you can see this, and click, and then go to your rise, whatever you want it to be, and then click again. So I've done 2 clicks to get the rise. Now you have to click on this point right here again to start the run. So I click to start, click to stop. I said this earlier, 4 clicks, okay? And then you count it out. So what overall would I type in as the slope of this line? 1. And I'm not going to put a negative on it because it goes uphill. So I'm just going to go slope of the line is 1. I'm going to hit enter twice and I'm good to go. Let's do another one. How about this one? What do we know? It's positive again, right? And as long as you pick any lattice point. So like, let's say I pick this one over here. Who cares, right? It's a lattice point. How far up do I have to go? For you guys, and then bless you. And then how far to the right do I need to go to get back to the line? Yeah, it looks like I need to come back all the way 4. So what would my slope be? 1/4. Very good. And again, if you were feeling crazy and you went like up 4 and right 16, okay, you weirdo, it's fine. It's going to work as long as you reduce that down still to 1/4. This zooming in is crazy. Wow. How about this one? Yeah, there was a guy last hour. I don't want to say his name because I'm recording right now, but someone in third hour said that what he does is when he sees a downhill line, the first thing he does, so he never misses him, he goes down to the box and he types in his negative. It's actually really smart to do. And then if you forget, then I already had it there. So pick a lattice point like this. Boop. How far down do I have to go? Looks like if I just go down 2, I'm good. Click, click, over 1, right? Down 2, sideways 1. What's the slope of this line? -2, not negative. And it's, yeah, and remember to simplify everything as much as you can. So if you get like 6/8, you're putting 3/4. If you get 10/2, you're putting 5. If you get 3/1, you're putting 3. Right? Do you guys have any questions about that? All right, that's what I have for you today. It's on Delta. It should be there. If it's not, I'll assign it real quick. And then tomorrow I have a packet of paper ones like this that we have to do by hand. Okay? Cool.
Yeah.